Hey everyone, and welcome. Today, we are going to get into something that so many people are talking about and, honestly, getting wrong. We're going to pull back the curtain on how these huge AI models, like ChatGPT and Gemini, actually learn. And I'm telling you, it's probably not what you think. So let's just get right into it.
All right, here's the big question, the one everyone's asking. You just hit publish on this amazing new article. Is there a secret button you can press to make ChatGPT read it and, instantly absorb it into its brain? Can you actually teach it in real time? I mean, if you're in marketing or SEO, you've seen them. All these tools and services that pop up promising they can get your content into ChatGPT or force Gemini to cite your website. It sounds so simple, right? Like you can just mainline your articles straight into the AI's core knowledge.
But what if the best, clearest answer actually comes from the AIs themselves? Yeah, we went ahead and asked Gemini, ChatGPT, and Claude to just tell us how they work. And they all basically said the same thing. Whoa, hold on. It's really not that simple.
So let's do this. Let's bust this myth wide open. And we're going to do it by looking at what the models themselves told us about what's really going on under the hood.
Yeah, we're going straight to the source. Our whole investigation here starts with the most basic question of all. How is an AI's brain? Its actual foundational knowledge. How is that even built in the first place?
And that brings us to the first of two really, really important processes. This is the big one, the construction phase.
The official term is model training, and Gemini gave us this perfect analogy. Think of it like building a massive, massive library. This is not about just running in to look up a fact. Oh no. This is the slow, deliberate, architectural process of designing the building, laying the foundation, and filling every single shelf from scratch. So what exactly are they putting on these shelves? Well, it's a mind-boggling amount of information. We're talking gigantic data sets like Common Crawl, which is basically a snapshot of a huge portion of the public internet. Then you've got cleaned up versions of that, tons of digitized books, scientific papers, literally all of Wikipedia, and all the public code from places like GitHub. The scale is just, it's hard to even wrap your head around. So how does this library get built? It's this huge multi-step process. First, crawlers go out and just collect that giant snapshot of data. Then comes this intense cleaning phase, stripping out all the junk, the ads, the duplicate content. After that, all that clean text gets broken down into these tiny little pieces called tokens. And then finally, the model uses an incredible amount of computer power just to learn the patterns and the relationships between billions and billions of those tokens. Okay, so here is the absolute key, the most important thing to get. This entire library building process, it's slow, it's insanely expensive, and it happens completely 100% offline. It's not happening live. The AI isn't browsing the web right now to build its brain. It's working from a library that was built and finished sometime in the past. All right, that probably raises a big question. If the AI's brain is just a static library, how in the world can it answer questions about stuff that happened, like, yesterday? Well, that brings us to the second, much, much faster process. This is something called generative search. The techie term is retrieval augmented generation, or RAG for short. So if model training is building the library, you can think of RAG as having a super fast research assistant. This assistant lives in the library, and when you ask a question, it can instantly run to find the latest info and give you a summary. And here's how that research assistant actually works. First, when you ask your question, the system figures out what you really mean. Then, and this is the cool part, it does a quick search on the live web, kind of like a Google search. It pulls in a few fresh snippets from the top results and hands that new information to the main AI. Then, the AI uses its huge foundational library knowledge to make sense of those new snippets and craft that fresh, conversational answer you get back. Okay, let's put these two big ideas, the library and the librarian, right next to each other. Because understanding this difference, well, that's the key to everything. And here it is. This is the aha moment. On one side, you have training, building the library. The goal is this huge base of knowledge. It's a massive offline job that only happens once in a while, maybe every few months or even years. The result is a static thing. But on the other side, you have generative search, the librarian. Its goal is just to give you a current answer, right now. It's a real-time process that happens in seconds every time you ask. The result is a brand new dynamic answer. Two totally different jobs. For those who want to get a little more technical, think about it this way. A traditional web crawler, like Googlebot, is out there 24/7, constantly updating its index of the web to give you a list of links. But a generative AI, it's trained periodically, offline, and its purpose is to generate new sentences. So one is continuous, the other is periodic. One gives you links, the other gives you a whole new answer.
So let's bring it all home. What's the bottom line here? Why does this whole distinction between the library and the librarian actually matter to you, to anyone creating stuff for the web?
Well, here's the big takeaway. You are not teaching the AI. You can't. What you are doing is creating the high-quality raw material that its research assistant, that RAG process, uses to build an answer. So your job is to make your content the best possible source material. That means focusing on clarity, using simple language, using structured data so your facts are easy for a machine to pull out, being factual and authoritative. You're basically creating the perfect source document for a very smart, very fast librarian to reference. And that kind of leaves us with this one last pretty wild thought. As all this technology gets better and better, are we still just writing for human readers? Or are we now also in the business of writing the ultimate high-quality cheat sheet for a robot? It's definitely something to think about. Thanks so much for joining me.